Hey, it's integer. It's Mr. Mackenzie and Mr. Romanovich. Here's our lesson on integer real-world problems. So get this down. Make sure you note that. If you need to pause it, pause it. If not, hey, let's go.
All right, he's quick today. All right, we're going to be solving some real-world problems, and the key to solving them is use a number line. Okay, it doesn't have to be a very detailed number line, just a kind of generic one to kind of show you where are the numbers. It helps us decide what do we need to do with those two numbers to help us find our answer. So I've kind of got a very basic number line, got our 0 in the middle, and we want to find the distance between these two numbers. So 53 and 35. So if I think about it, 35 is maybe about here, 53 is about here. So I want to find this distance between the two numbers. Well, if I want to go from 35 up to 53, the easiest way to do that is simply do a quick subtraction problem. 53 minus 35, what's the difference between those two numbers? Do a quick little borrow here, and I get a difference of 18. So it would take 18 to get from 35 up to 53, or in reverse.
So then you've got something like negative 30 and 15. So now we're going to work both sides of the number line. Our negative 30, of course, is on the left, and our 15 is on the right. And Mr. Mackenzie asked me this before we started the video. Now I remember what I kind of told kids is that we're going to make this trip from negative 30 to 15. It's sort of like taking a train trip that has a stop in the middle. So our first leg of the trip is to go from negative 30 to 0, and then to go from 0 to 15. And then we're going to add those two distances together. So if it's negative 30 to 0, that's 30 steps. And if it's from 0 to 15, that's 15 steps. And if we put those together, we know the distance between the two is 45.
All right, so that one went over top of the 0. So we kind of had to do a distance to 0 and then on to our next number. Our last one is negative 50 and negative 90. So these are both going to be on the left side of our line, the negative side. So let's say negative 50 is here, negative 90 is here. And again, we're just trying to find the distance from one number to the next. So we want to go from 90 back to 50. Well, a lot of us can probably do that in our head, to go from 90 to 50. That's just a difference of 40. But if we're not sure, we just do a quick subtraction problem. 90 minus 50. Notice when we're subtracting, we don't worry about whether it was a positive or negative number. They're both on the same side. So we're not really worried about the signs. We just want the difference between them. 90 minus 50 is 40. So we have a distance of 40. But that number line helped us visualize, did we want to add the two numbers together like we did for Mr. Romanovich's example, or are we just going to subtract the two numbers to find their difference?
So sometimes you've seen some vertical number lines and they're really good for temperature problems because that's what we're really used to seeing is temperature shown to us in a vertical way because that mercury goes up and down, it doesn't go left to right. So if you look at a problem like what is the temperature change from negative 12 centigrade to positive 13 centigrade, we would start at negative 12 on our number line, which is below 0, and then add a value of positive 13 above 0. And then I would do the same thing I did in the previous one. I'd take that first train trip up to 0, that's 12 spaces. Then take the next leg of that trip up to 13, that's another 13. And then find the sum of those two. 13 plus 12 gives me 25 steps. I think it was only going to say 27, but that's not right.
All right. Next one, what's the temperature change from negative 18 degrees Celsius to negative 3 degrees Celsius? So I can jot my quick little thermometer, or my temperature here. Negative 18 is going to be way down here in the negatives. Negative 3, it's close to 0, but it's still on the negative side. So with Mr. Romanovich's idea of kind of taking a train trip, here I can go right from negative 13 to negative 3. So I'm going from 18 down to 3. Well, that makes it sound like, oh, let me clean up my mess there. I want to go from 18 to 3, so I just want to find the difference between them. So I just need to travel 15 degrees. Since they're both on the same side of our number line, we just want to subtract them to find our answer.
So as with everything, we are going to use the same concept, just make the numbers a little more complicated. In the first example, we have the difference between the record high and the record low temperatures in the United States. The record high, so that's going to be on our positive side, is 56.7 degrees centigrade. Then the record low was negative 62.2 degrees centigrade, which I think was last January. That's why we had a day off. And then finding the distance between negative 62 and 62.2 and 0, that's my first job. So if I see that as 62.2, then the second half of my trip, I've got to get to 56.7. That's 56.7. And because we crossed over that 0, we're going to add the two together. So 62.2 plus 56.7 is 9, 8, 11, 118.9 degrees centigrade.
That's a big difference in temperatures in a year.
Huge.
All right, next one is, now we want to do the same thing in Fahrenheit. The difference between the high and the low temperature. So I set it up nicely, so I got to do the one with the nicer numbers in it. Mr. Romanovich got the negative, or got the decimals in there. So we have 0. Our high temperature was 134 degrees Fahrenheit. Our low temperature was a frigid negative 80 degrees Fahrenheit. But same idea. It takes 2 stops to get from one to the next. To get from negative 80 just back to 0 is going to take me 80 steps. And then from 0 up to 134 is going to take an extra 134 steps. All told, we want to combine those together. I'm going to run out of room here. I get 214 degrees Fahrenheit in difference. That's a huge difference. 200 degrees that's a weird year. I'm just going to go with that.
Okay.
Last one.
And now this takes some visualization. So if you're thinking about this, think about how high you are on a mountain and how low you can be in a valley.
So let's draw a mountain.
Perfect.
And here's sea level, even though it's green.
And then Death Valley, then, as we see in the problem is Death Valley is actually below sea level. So at the top of our mountain, we're at.
Sorry, I need some.
Oh, I like that. At the top of our mountain, we're 163 meters. That's a positive. And then in the bottom of Death Valley there, we're at negative 86. And so this goes back to the idea of what is 0 here. And here 0 is actually 0. It's sea level. So if we know that's 0, then we know we've got to take that one-stop train trip, or 2 stops, or 2 legs, I should say. It takes us 163 steps to get back to 0 from a 163. It takes another 86 steps to get to negative 86. And because they're on both sides of 0, we're going to add them together or find the sum. And that would be 249. No, I did not do that fast. Mr. McKenzie did that fast. I just stole the answer.
That's right. So hopefully you notice that drawing a picture, whether it's a very bad mountain and valley and the sea level that goes with it, or a number line with some basic information, really helps let you see how do I need to set up this problem as we try to solve it. Have a good day.